Everybody, myself Jyoti. Yes, Nobel Prize in Physics 2020 was announced on Tuesday, 6th October 2020, and it is for the massive discovery of black hole. So, if you are studying physics, then you must know about this. So, the trio, Roger Penrose, Reinhard Genzel, and Andrea Ghez, this trio got the Nobel Prize in Physics 2020. Roger Penrose shares 1/2, that is half of the Nobel Prize, for the discovery that black hole formation is a robust prediction of the general theory of relativity, while Reinhard Genzel and Andrea Ghez, they share one fourth of the Nobel Prize for the discovery of a supermassive compact object at the center of galaxy. So, three laureates share this year's Nobel Prize in Physics for their discoveries about one of the most exotic phenomenon in the universe, that is black hole. So, what are black holes? A black hole is formed when stars collapse and can be defined as a space in the universe with escape velocity so strong that even light cannot escape it. So, next question is, what is escape velocity? So, escape velocity, it is the speed at which an object must travel to override a planet or an object's gravitational force. For example, a spacecraft is there and it wants to leave the surface of Earth. So, it needs to be traveling at a speed of about 40,000 km per hour to escape Earth's gravitational field. Now, black holes, they are invisible. They can only be tracked with the help of space telescope or other spatial tools. And the reason light cannot escape is mainly that the gravity inside a black hole is very strong as a result of matter being squeezed into a small space. So what do award winners' work tell us about black holes? So Penrose's work has shown that black holes are a direct consequence of Albert Einstein's general theory of relativity. In fact, Einstein himself did not believe that black holes exist and presented his theory in November 1915, providing a new way to look at and understand gravity that shapes the universe and the largest scale. What is so great about gravity? Gravity also shapes space and influences time. It is this gravity which is so great inside a black hole that is able to bend space and slow down time. So, Penrose's contribution, he used Einstein's general theory of relativity in order to prove that the process of formation of black holes is a stable one. That is the first thing. He proved that black holes exist and described them in detail back in 1965, 10 years after Einstein died. Genzel and Ghez, on the other hand, have discovered that an invisible and an extremely heavy object governs the star's orbit at the center of the Milky Way. This extremely heavy object has the mass equivalent to 4 million solar masses and is packed into an area about the size of our solar system. So it took 5 decades. Essentially, their work tells us that at the center of our galaxy, the Milky Way, lies an invisible supermassive object of which a black hole provides a reasonable explanation. Physicists have been suspecting the existence of black hole at the center of our galaxy for over 50 years now. So it took 5 decades to prove the existence of black hole. What did they actually do in order to see through to the middle of the Milky Way? Genzel and Ghez worked on developing methods and used some of the world's largest telescopes. By observing the orbit of the stars that are closest to the center of the Milky Way, The physicists think that the black hole could most likely be hiding in Sagittarius A, a source of radio waves around which all stars in the Milky Way orbit. So, in other words, the existence of a black hole at the center of our galaxy is what the physicists believe is what pulls a jumble of stars, causing them to rush around at dizzying speeds. So, where does research on black holes go from here? While work done by Penrose has established that black holes are a robust consequence of the theory of relativity, that is, first, they are formed naturally in very overdense regions, second, and formation is a stable process. The theory keys to apply at the center of the black hole. So he has proved this 3 points, but the theory keys to apply at the center of the black hole. That center of the black hole, it is called as the singularity. Singularity, it is a boundary at which all the known laws of nature break down. So this essentially means that the extent to which the general theory relativity applies to the structure of black hole requires further probing, and questions about the internal structure of black holes still remain. So still there is a lot of scope for all of you to look further into this research area. Thank you. Thank you so much.